Okay, so now uh import pandas as pd. That I think, let's see it required or not. Import numpy as np. Okay, so now just I assume that some value is present, 950, 970, some value, just okay, 450, 480. These are the some value, and I want to identify the mean. This is suppose subsample data, or you can say suppose assume that this is the marks, your marks in the some subject, okay. And now I try to identify the mean. Mean means nothing but the average, right? It is the average only. So how you can identify? So there first I just try to give you the basic calculation that you can do like that also in the Python, that how to do the addition, subtraction, and how we can pass the exact function, that also I will tell, okay. So 970, 450 plus 480, okay. So this is the summation, and if I divide this summation by how many, 1 2 3 4, so 4 you will get the mean, or you can say average, okay. Now one more, okay. This is means I suppose there are 10,000 data and any data, so this is not feasible way. This is just I'm telling you, okay, you can do this small calculation in the Python easily, okay. Now okay, I want to identify the by use of the mean function, okay, what is this, okay. So suppose if I pass x is equal to this only, 950, these are the your entire data. Suppose I assume that 970, 450, 480. So this is the x, and now in numpy there is a mean function is available. You just need to pass the mean and you will get the mean, okay. So these are the means some basic thing, but you should know, okay, how to do in the Python. So that's why I'm telling you, you will get the mean. Even means many data present, you will easily get by use of the np dot mean. In the pandas also you can pass the pd dot that column and dot mean. If you write, then also you will get, okay. But by use of the numpy also you can do. Okay, so all these four data set, suppose you taken and you getting the mean is 4, means all have a same thing, same nature. No na. So on what basis you are telling a mean will give you the some information? Okay. So now in that case, okay, you will identify some middle point of the entire data set. That is the good thing. Okay, no issue. But again, with respect to the mean, how much varies your data? That is also one critical part. Okay, means one important task, means you can say in the data. So how much vary? So that you can identify by use of the variance, right? And maybe you people aware about the variance. Are you aware about the variance? Aware? Okay. So if now you have mean, all the for all the data mean is equal, but how much it varies with respect to the mean, that is also means some characteristic, or you can say the nature or information about the data set. So when I talk about this one, so all the data at this particular point only, okay, at a center. But when I talk about this, so here the data is vary with respect to the mean. Okay, so when I take the variation for this one, first one, so what will be the variation? 3 minus 4. So here I will get the minus 1, here I will get the plus 1, means when I compare with the 4, okay, here I will get the plus 2, and here again minus 2. Okay, so here you can see the variation with respect to the mean. Okay, so now here also you can identify like that. So variation will give you the idea about the means how much our data vary with respect to the mean. Okay, so now variation you can identify, but here when I talk about the, okay, this 4 means here how I identify 4, 3 minus 4 is minus 1. So overall variation for this data what will be? Means you can't do means simple addition, right? So what I need to do, I need to do, okay, 3 minus 4 square plus whatever the next point, 5 minus 4 square plus what is the next, plus 2 minus 4 square. Why I did the square? Because I want to eliminate that minus thing. Okay, whatever the minus will come now, so I am not because they that will impact. Okay, I want overall variation, so I need to do the square. And when you divide with the n, what is the n? Means total number of values, you can say, that is a 4. You will get this is nothing but the variation. Okay, but I did the square. So here one more term is coming after that, that is the standard deviation. And standard deviation is nothing but the under root of the variance. Okay, so many book are using this is as a sigma square and sigma as a standard deviation. Okay, so what is the standard deviation? It is again the thing which is useful to measure the distance with respect to the mean, means how much variation in the data set with respect to the mean, that you can measure by use of the standard deviation. Okay, any doubt? Okay, so now okay, so I want to measure the standard deviation of this data. So just what you need to type std and you will get the answer. Just pass your x and you will get the answer, that is a 247.82. Okay, you want the variance, so variance also may be available, I think. Let's see, is available or not. You can see, so when you do the under root of this value, you will get the standard deviation. Okay, you will get the standard deviation. So now the next point, when we talk about the again the data, so what is the point is here, when I talk about the data. Okay, so data, this is the mu, or you can say mu is equal to nothing but the mean. Okay, so it will, this is the midpoint of your data set. And some data, means when I talk about the my bike average speed and the mean speed is the 40 or 50, assume that 50 kilometer per hour is the my average speed. So sometimes speed will be more than 50, sometimes speed will be less than 50. Okay, so sometime you will get the data in the this left side, sometime you will get the data in the right side. Okay, now when you take, means when you make a density graph, so you will get like this. Okay, so near to the mean you will get more value, and after that again the number of the count will reduce. And this is nothing but, you can say, the it on the basis of the frequency, or on the basis of the what we can say, density, you try to plot this graph. Okay, so how to, means if you have some data set, what you will be do, you will divide that data on the basis of the class, right? Some class, means suppose their range is the here the 50, right? So what is the range of your bike speed? That is the 20 to 80. So you will divide that into the small class, and you will put the count. Okay, so you will get like that. Okay, this type of the graph you can plot as a histogram, and that show you the distribution of your data set. Okay, so if you take this class number is very small, then you will get this continuous line, that is the distribution plot, and that we already did in our SNS library, right? In SNS library, SNS dot this plot, and you can pass the value, you will get this thing. Okay, so that we did already. So now what is the thing is here, your maximum data will be near to the mean. Okay, normally it will be near to the mean. When I say the speed is, my speed is the 50 average speed, so my speed will be vary, sometime means 45, sometime will be, means maximum data, means I'm not a maximum time my speed will be 20 in that case, and maximum time my speed is 80. It is not like that. It is very with means the more data you will get near to the mean. Okay, so this type of the thing is nothing but the, you can say, the normal distribution. Okay, got the point? Now again after that in the stats one concept is came. Okay, when we talk about the probability, are you aware about the probability, right? You are aware about the probability. So when we talk about the probability, what is the probability? Means the number, means event you can say, and number of the total possibility. Okay. So when I means toss the coin, their total number of the possibility is 2, and if I tell ki what is the chance of head came, okay, so that only one here one event and divided by the total possibility, so you will say ki that is the 0.5, 50% chance ki head will come in general. Okay, so there again you can do, when we talk about the data collection part, there are two things you can say. The one is the observational and one is the experimental. What is the observation? Means I just try to observe the temperature of the this Mumbai city. So I'm just observing. Okay, today temperature is the 30, tomorrow the temperature is 31.5, day after tomorrow means, and the yesterday the temperature, whatever the historical data present, that you try to observe only, you unable to control that data. So observation, so that data if you collect, that is the observation only. The next point is the experimental collection. Means in the, suppose I take some research is going on in the medical industry, they will give you the one means amount of the particular drugs. Okay, so like I will give the 5 mg today, and let's see what is the result next time. Means they have a control about that quantity, about that particular thing. Okay, so they can give 1 mg also, they can give 2 mg also. That is the experiment. Means on the, means if you able to control the that particular variable, and on the basis of that you try to predict, means you try to collect the result, that is nothing but the experiment. Are you getting my point? Any doubt? Okay, so now where we are? Okay, huh. So normal distribution is done. So now many time means again in the probability two thing will become, and when I talk about the probability, means I am talking in the terms of the inferential stats. Okay, here I am not talking about the summarizing the data, visualizing the data, whatever present historical. I try to predict something in the future. Okay, so that's why I need to collect these uh, means p value and all. Now uh, okay, so this is done. Now when we talk about the probability, again probability with respect to the what we done, this coin, there is the two possibility, right? Head and tail, only two possibility. So that is the discrete, you can say. There not, you will not get ki head is 0.25 and tail is 0.75. This type of the thing you will not face. Okay, so there two was, if I talk about the dice, there are six possibility. Okay, so sometime will become two, sometime will become three, and if I say कि how, what is the probability to come one, so what you will be do, the number of event is one and divided by total number of possibilities, that is the six. So 1 by 6 is the probability to come any number. Okay, so any doubt? So here discrete means 1, 2, 3, 4, 5, 6. You will get the data in the discrete manner. So discrete probability. When I talk about the continuous, okay. So continuous means what we can say. Okay, so here means you have a score of a particular subject like operation analytics, and you have a score. Someone has a 7.5, someone has a 7.75, someone has a 2.5. These are the marks. Okay, and if I say कि what is the probability student will get the marks exact 7.5, what is the probability? And 7.50, 51, let it be. What is the probability you will get the marks out of 15, 7.52? Huh? Means I taken the your midterm, 20 marks midterm. Okay, and I will tell कि what is the, if I take the Yash example, okay, what is the probability कि Yash will get the marks 15.15 out of 20? What is the problem? इंटरव्यू में पूछ लिया तो 100%. 100% you will get 5.12. If you get 5.125, 5.11, then Okay, so what is the here? If I talk about the 5.12 exact, that is the only one event, right? So what I need to do, this is the one event divided by how many number of possibility, total possibility. You will get 5.11. You can also get 5.12. You can also get 5.13. You can get 5.135. How many? Infinite. So what is the probability? Zero. So when we talk about the continuous data, continuous, there if someone say कि okay exact point and someone say कि what is the probability, you need to say कि zero. You unable to identify. But someone say कि what is the probability कि Yash will score in means in the range of 10 to 15. So you can easily say in that case how that we will discuss. Okay. So now for continuous data set, okay, continuous data set, there is the one theory is development, that is the they assume that the data is distributed about the mean and the area of this graph is nothing but the one. Okay, and that indicate probability. This area of the graph is indicate the probability. Okay, so now the next point, how to calculate the area, that already done by some researcher. Okay, and that is nothing but the z table. So what you need to do, you need to convert your data into the z value, and by use of the z value you can calculate the probability. You can calculate the probability. Okay, so any doubt? theory part है maybe अच्छा नहीं लग रहा है, but we will actually this part is also necessary, okay, when we talk about the analytics. Okay, क्या हुआ break? Okay, so numerical data you need to pass and then only you can calculate the z score, mean and all. Okay, so what the thing is here, you need to convert that whatever the data you need to convert into the array. And what is the array? Array is the collection of the data which are the numerical. Okay, numerical only you can consider. So there is a difference between that, when we talk about the what is the difference in the list and what is the difference in the this what is the difference in the where we are, huh? Array and the list. Okay, so when we talk about the list, that is the collection of any type of the data you can collect inside the list as a variable. Okay, means even nomenclature, complex value, any value you can put. But when we talk about the array, you need to put the numerical data. Similar means numerical, like you can put like 6.7 also, 6 also, integer also, means numerical in short you can say. So now I have some value. Okay, so what I need to do, some value like I just taken like 6, uh, these are the values 6, 7, 8, and what you need to do when we take the some data set, you need to consider this value as a column, right? So that we will do. So 6, 7, 12, now 13, 13, 13, okay, 13. Mhm. So this is the value. Okay, so what I need to do, I need to pass this value as a data, and I want the mean and the z score and all the thing with respective this. Okay, so now uh, okay, so what is the point is here, if, when I say okay, what is the type of data, okay, type of data, so it will tell you okay, that is the list. Okay, so now I want to convert this thing into the Z score. So let's see, means when you want to calculate the Z score, it may be show you the error because of list, but let's say it show the error or not. So first, for doing this stats type of the thing, there is the one library, that is the SciPy, that you need to install. If not, because I think that is by default installed during your Anaconda installation. So just import SciPy, and if not work then you need to install. Okay, dot stats as a stats. Okay, So installation is done or it show any error? What error it shows? SciPy is not available. Means that is not available. So pip install do it. So here np.mean is 30.1 for this data. Now you have x minus mu divided by sigma. That is the formula, right? NP is not import numpy as NP na. Then ऐसे कैसे NP तो कब से डिफाइन किया है? Okay. Now if I can try to calculate the standard deviation. So this is the standard deviation. Okay. So what is the Z score? When I talk about the Z score, is nothing but x minus mu. For 6 I want to calculate. Okay. So 6 is the first value in my data set. So 6 minus np dot mean. This I can pass directly for making the in the dynamic nature. Let's see it will work or not. And divided by np dot standard data. And now if I say okay, what is the Z score, just let me check. This is the Z score minus 1.4, 1.44. Okay, so what is the mu here? Mu is equal to what? 13.1. Okay, now the next part, what is the mu is done? Standard deviation sigma is equal to what is the sigma? 4.90. So when I draw the normal distribution graph, this is the graph, and this particular point is nothing but the 4.9. Okay, if I convert this 4.9 into the Z, what the value will come? Mean is 4.9, right? And if I want to convert that into the Z with respect to the Z, what will be the mu minus mu is equal to 0 na? So when we talk about the normal distribution, the mean is nothing but the Z. Okay, so here that is the Z is equal to 0, you can say. And here what is the value of Z score for 6? So we know that 4.9, after that this is a 4.9, and we try to calculate the Z score for 6, so that is the minus 1.44. So where it will become? It should become, are mu is 13.1. I'm sorry. Okay, 1 minute. Eraser is available. Okay, mu is 13.9, 13.1. So at a 13.1, the Z is 0. Are you getting my point? So some value will be get right side, some value will be get left side. Okay. So now when we talk about the 6, 6 is the left side. It will come here somewhere, na 6. And at a 6, what is the Z value? That we calculated minus 1.44. Now you have this data, and someone will ask, okay, what is the probability the number will be after on the basis of this data? What is the probability the next number and the coming number will be less than 6? What is the probability that you need to identify? Less than 6 means I taken the randomly any number from the data set, and in that data set what is the probability I will pick up the number which is less than 6? How to calculate? No, you know the Z score, right? And what is the Z score here? That is the minus 1.44. And what is the area? This is the minus 1.44. This is okay. I able to change the color here? नहीं ना हो सकता है क्या? हाँ. Okay, so this is the point, right? This is the minus 1.44. So यहाँ पे जो area है with respective left hand side, it shows less than 6. and this area will tell you what is the probability. Okay, so how to check that value? By use of the Z table that already made by some statistician. Okay, so let's go for the Z table and identify what is the p value, and that I can do with the one line in the Python. I can easily identify, but you should know the concept. Okay, that's why I'm doing all these things. So let's go for Z score and Z table. I'm sorry, Z table. Sorry, click at another place. Z table. Okay, so when we talk about the Z is equal to x minus mu divided by sigma. Okay, so x minus mu divided by sigma, and let's this is the Z score. How to interpret the Z score and all. What is the value? Minus 1.44, and this is, you can see, it is means when Z will be increased, the area it's showing like that. Suppose Z is here. Suppose I will take one. Suppose Z is here, so you will get this area. Okay, this area, this entire area you will get in the Z table. Left side all area you will get. Okay, so let's uh, remove. Okay, so I quickly one minus 1.41. So minus 1.41, I think you aware about that, right? How to read the Z table. So this is the minus 1.4, and this is the minus 1.4 actually, and this is minus 1.41. This is minus 1.41. 1 minute. Left side, minus 1.41. So minus 1.41. So what is the value? 0.079. Okay. So you can say probability 1.44. Okay. So 1, 2, 0.749. So 70 means 75 and 74.9 is the possibility. Are 7% probability. I'm sorry. So 0.749. Okay. Now I go to that thing. I think we okay. So like that you can calculate. Let me 1 minute. Let me identify with the use of the stats. Their stats is we just import it. Okay. And now I don't want to calculate that all things. Suppose you want to do for the entire data set and you try to identify means what is the Z score. So how you can do stats and just type the Z score. Okay, and for Z score for what you want entire data is the Z score. So you are getting here minus 1.44, minus 1.24, and minus 1.44 that we calculated manually also. Okay, and what is the point is here कि each Z score tell us कि how many standard deviation away an individual value from the mean. Okay, so for example if you take the 6 that their standard deviation is minus 1.44, so you can say that is the left side. Like that you can interpret in the graph. Okay, distribution plot SNS dot is 1 minute. I think import SNS Nasibon. Are you able to show now? That already we discussed in the I think, earlier session, right? And हाँ, जूम इन करूंगा तो ग्राफ नहीं दिखेगा, अभी क्या करूँ? Now you able to see na, like that you can plot. That already we discussed in the data visualize. You one more thing means in the uh, suppose you don't want to see this warning na, many times this warning will become na, and you don't want to see, then also there is the import warning, and then you can do the warning dot filter, filter warnings, and that you can ignore. Now that warning will not come. What happened? Import warnings. Okay, as I missed as. Okay, so warning will not. You can see like that. This is the density with respect to the your data, and what is the mean? You know that that is the 13.1. With respect to that, this graph is made. Hmm. 1 minute. By use of the stats.z score, you can calculate the z score for your data. And manually also I calculated x minus mu divided by sigma. Okay, let's go. And now in stats, okay, so this is the again this is what you need to do. Stats, this is your library, right? In stats I will call the normal distribution norm, okay, dot cdf, cumulative density function. That is the cdf inside the python that you need to remember. Okay, so stats dot normal distribution dot cdf. Okay, and now I want the probability, right? So what you need to do, you need to pass the value of your value. Okay, so I want to probability for 6 that we calculated, right? Some 7% we are getting. So for that only we try to calculate. Okay, so what you need to do, first pass the your value, that is the 6, right? Okay, now what is the location, or means I'm sorry, you can say what is the mean that we need to remember. And mean is actually indicating the location in the graph, right? That is the mid value, you can say. So what you need to do now, pass, when you press the shift tab you will get, okay, get the answer what you need to do in this function. Okay, so when I explore here, x you need to pass, that is the your value. Okay, the next point is the location. Loc means there it is a location, by default it is a 0, it is, you can say, it is a mean. Okay, and when I talk about the scale, scale is nothing but the standard deviation. Okay, so let's pass all these three value. Now first I try to pass the log, and in log what is the value? Okay, 1 minute. In log actually something is, हाँ वहां पे डाल सकते, लॉग पर अपना क्या था इसमें, लेट, हाँ, so that is the 13.1 directly I try to take, right? 13.1. And what is the standard deviation? Scale is equal to, what is the standard deviation value? uh, where it is 4.9, 4.90, let 4.90. And your this percentage you will get, that is the 0.73. Okay, so directly also you can get, say like 7% chance कि there the value will be less than 6. Are you getting my point? Location is nothing but mean, na? So 13.1. You need to put mean there. Mean is actually indicating the location. Ah, you can put 0 point. Ah, so that variation. Ah, so that a small variation you will get, because what is the thing here? I'm not passing the data. Are you getting my point? I just assume that is a normal distribution, and above data that is not that much normal distributed. This is actual data. That is not that much, okay? But you are getting approximate same way. Are you getting my point? I am not means tell ki these are the my data. I just pass ki okay, that is the normal distribution. This is the x. Just calculate the percentage, and it will give you the approximate same way. So that's why the stats is useful. No need to do entire means data calculation and all. Just pass the location, standard deviation, and the your means for what you want to calculate the probability. Here I want to see how many number of the student who will score less than 6, that I want to know. Okay, so that you can calculate easily. Okay, there are 7% student, means approx 7% student will score less than this what is the value below 6. Like that you can interpret the result. 1 minute, so I quickly go. So this is the okay. So here we plot the distribution plot, and now this is the p value we can easily calculate by use of the stats dot norm and cumulative density function, and you got the 7% chance the student will score less than 7. After that Excel import, this is the one data, and this is the mean calculation for the one column. Okay, as well as the median also calculate. So are you aware about the what is the difference between the mean and median? That you aware, right? Means median, mean is nothing but the average. Median means you will keep all the data into the ascending order, and the what is the middle value? If that is the means you can say the odd, then you will get the one middle value. That is nothing but your median. Okay, and when it is a even number, then you need to take the middle two value, and that average is nothing but the median. Okay, so what is the purpose behind that? Why we need to calculate the mean and median? It give you the idea about the outlier, okay, how many outlier present inside the data. After that you can easily remove. Okay, that's it. Okay, we try to discuss that how to remove the outlier also, because that will be with the part. Now we need to remove the outlier, then only we can make the regression proper. Regression, linear regression, and all things we can do proper. Okay, so I think you aware about the mode also, right? Mode means that is the maximum frequency of the any data. So what you need to do is stats dot mode. Just pass the mode, that function available inside the stats. You will get the mode, and there you can say 92,000 is the more frequently occurred value in that particular column. And you are aware about that. The max mean, how to calculate that already we discussed. X dot max you will get the maximum value, at x dot mean you will get the minimum value and all. So that I think we discussed, and even you can pass the mean and inside that x, and you will get inside also you will get. These are the two way to write. Okay, so don't worry, you can write like that also. Okay. Okay, and many time, okay, you may be saying I want to know the mode of entire Excel. Okay, so entire Excel also you can calculate the mode, mean, anything. Okay, so what you need to do is stat. I think it's stats dot mode, and pass that entire DF. Then also you will get the value. No issue. So for first column there is the professor, that is the maximum occurring, the frequency is more for this data. In second, B is the more frequent. In third, you can say this one male, and 92,000 is the more for the salary. In gender, more male are present compared to the female, like that you can see. Any doubt? और साथ में करो हाँ, variance and all things done. Okay, so like that you can do the all the thing for the, what we can say, for the Excel file also, and for the means data set also, there you can easily identify mode, median. You can identify someone say ki what is the probability ki the faculty will get the less than 57,000. You can calculate easily. What the we did earlier, that same thing you need to apply. Okay, just you need to change the variable and you will get the answer. Cool doubt hai? Okay, so now one very interesting concept that I try to discuss, and that is actually important, the outlier. Okay, so when we talk about the outlier, means in any you have a data set, and someone will give you the data set, like we will take that data in the linear regression. Okay, like the expenditure on the TV advertisement, expenditure on the radio advertisement, and the newspaper advertisement, how means impact to your sales, product sales, that data suppose is available. Okay, now in this case the data is available. Okay, so many time outlier will be present. Okay, okay, like even if we talk about the restaurant, their tips related data we analyze, right, in the previous session. So you know that someone will give the tips, means very rich person, and they give the tip like 1000 also, and the general is the 100 rupees. So that 1000 is the outlier in that case. Okay, so how to remove the outlier, that we need to discuss. Okay, so there are the different method for removing the outlier. So we try to discuss the Z score base, how to remove, as well as the box plot base, how to remove the outlier. 1 minute, huh? We try to discuss. Okay, so mode and all things done. Now, why we need to calculate the Z score? So let's this is your data set. Okay, and I assume that it is goes like that. Okay, so this is the at a center, this is the mean, right, and this is, you can say, that is nothing but the Z is equal to 0, right? Mean, at a mean Z always will be 0, right? So with respect to the mean, what is the distance that we try to identify in terms of the uh, standard deviation? That is nothing but you can say Z score, right? So for mean, the distance of mean is obviously 0, so that's why we getting the 0 right now. Now Z is equal to 1, take here. Z is equal to 1, take here. Okay, I try to change the color also. Okay, so now you change, means Z is equal to 1 here, and Z is equal to 1 minus 1 actually, and Z is equal to minus 1 and plus 1. These are the two value. Okay, and when we take this minus and plus 1, I'm sorry, I not taken the properly, but please, means both have a means equal distance, consider that. Okay, so when you consider this area, so what is the thing, means as per the stats say ki in this area your 68% data will present. Okay, 68% data present in this area. Okay, and we know that the maximum data vary with respect to the mean only. If we say ki, okay, the data is proper, in that case this condition should be satisfied. Okay, now when I take Z is equal to 2, and here Z is equal to minus 2, so in this thing, okay, so in this term what will be the thing will come, this will say ki your 95% data is present in this area, right? Okay, and when I take this one, means Z is equal to minus 3, and Z is equal to plus 3. In this case, suppose this is here, okay, so z is equal to plus 3 minus 3. So entire area means if you consider, so 99.7% data will be present in this. So this is the Six Sigma rule, okay. In generally the company say, okay, means out of 1997 product is accurate as per the dimension, then you can say our company is following the Six Sigma rule. In this case also, the means what is the point when we talk about the distribution of the data, it is means the maximum chance that the data will be under minus 3 sigma to 3 sigma. If any value goes out from this 3 sigma, means if any value their z score is minus 3.9, that is the outlier. If any value their z is equal to plus 4.1, z is equal to 3.2, these all are the outlier, and you need to remove this outlier in the data. You need to remove, then your prediction, your whatever the analysis will be more accurate. Are you getting my point? So it is helpful in that case, okay. You can remove the outlier. Any doubt? कुछ है? Doubt? पक्का? Okay, so we try to use this concept and try to remove some outlier, okay. थोड़ा सा टफ होगा अभी, तो थोड़ा ध्यान रखना. Now let's make one function, and means we try to means what how to calculate the outlier on the basis of z score. When the z score is greater than 3, I will remove that value. That's it. And that I want to apply in entire value, right? So I will not do for single value. I want to apply this concept in entire table, in entire column. So what I need to do, I need to make one function, and when I call this function, like you have one function sum, then pass the value, you will get the answer. Even for the 10,000 value, you will get the sum. The same concept I want to apply here. When I pass any value in the outlier function, I will get the answer. I don't want to do the repetitive thing, okay. So what for that you need to make a one function, okay. So what you need to do in outlier, this is the outlier I just made one function, outliers is equal to, I just put the right now empty, means here the outlier will come, okay. So first I need to define, means when you make a function, this may be difficult because this is more coding related part, but please try to understand, you will understand how actually it is work, okay. So define, and there what I need to do, detect outliers. Outliers, that is the name, you can put any name, you can put your name, the outlier also, just out also you can write. This is the name of the function, you can write anything, okay. So I just written the detect outlier, and what I will be do there, you need to pass some data, you need to pass some data, right? So what I will write, just data you can write x y anything you can write, it will not impact, it will give you the same result because that is the variable. I just written here data, you can write x, you can write y, it will not impact, it will just tell you when you write this function, like when you write some function, what function we taken mean, their bracket na, in mean you need to pass some value, so that is already something is defined x y something, so I just put there data. Data means you need to pass something inside that bracket, okay. Now this is a function I started, for started you need to use this column, okay. Now threshold, generally the people are taking the threshold is equal to 2 because 95% data present inside that na? So I just write the threshold, okay. Now how to calculate the threshold, you need to calculate the z value, right? And what is the z value? Z value is nothing but the x minus mu divided by standard deviation, okay. So z is equal to, or before that I need to calculate the mean. Mean is equal to NP, okay, dot mean, and this mean whatever you will be pass. Here you pass the data, so here also you need to pass the data. Here if you pass the x, then you need to pass here also x. Okay. Now I will explain when it in the working condition, that time also I will explain again. Okay. So standard deviation. What is the standard deviation? NP dot std, and again pass the data. This is the means this thing needed, then only you can calculate the z score. Okay. Now what the thing means when I talk in terms of the column, na, okay, I take the one column. Now variance, why standard deviation is nothing but the under root variance. Okay. Where we are, okay, so now this is the column. Suppose this is the salary column inside your data, right? And then 92,000, then 94,000, then 56,000, something is there. Okay, these are the things. Now when I pass the data dot salary, this is the one data, just assume that. Okay, data dot salary, so here all this column value will be passed. So I want to first calculate the z score for this one, 92,000. Then I want to calculate for next I want to do this type of the thing. The same concept I want to apply. What we applied here, the same concept I want to apply here like that for nth till n. So for loop you need to apply. Okay. So let's go and apply the for. So for again for I in, you can write anything instead of I, you can write anything in where data, in data, right? Now z underscore z score I just write, you can write anything. So z score, what is the z score? That is the first value is 92,000 in that column, that is the I. Okay, so I just consider that is the I minus what is the, what you need to do, mean mu divided by standard deviation, right? And now I need to apply, if standard deviation is greater than 3, then that is the outlier. If standard deviation less than 3, then it is not outlier. And what I want outlier only. Okay, so I need to apply again if else condition. If greater than, then put inside that list, otherwise don't put. Are you getting my point? So what I need to do, z I'm sorry, if now NP, you need to use NP dot absolute. Why absolute? Because many times you will get minus 3.9, many times plus 3.9. So when I apply the absolute, it will convert all the value into the plus. Okay, so minus also will be converted into the plus. So NP absolute. Now what you need to pass here, z score, and that is greater than threshold. I directly take, so there will be no spelling mistake. Okay, then this is the if condition is written, outlier, then you will get the outlier greater than, then you will get the outlier. Outliers dot, what we did means append, when you use the append function, it will add that particular value outlier inside the list, whatever the empty list is available here na. If you get the outlier, it will add that particular element inside the that empty list. Okay, so what I need to write, append and pass I means here greater than, so that's why I want to pass. And next I just return the yields. Another yields I'm not worry about the yields. Another means whatever they get, that I'm not worry about that, right? So only if I applied, okay, no need to apply other thing. So now here for entire function I need to start, this function is started here, and this is the gap you need to give, okay. So first it will pass to this line, then it will go to the next line. It's depend. And once it is executed in any function, you need to, you want some outlier, right? You want means here something written, means something should be output of this function be expected, right? What output we expected? Outlier only, right? So what I will be do, return and write the outlier here, outliers. So this is your function. Okay, so क्या करें अभी? What will be the next? Just pass the data and let's check it able to detect or not. So I take randomly data and first I will check, okay, it will work or not. So data, and what I will take, some data you can take like what we can take, one, okay. What is the function here? Function is detect outlier. This is the function. There I need to pass the data, okay, and even you will confuse, so I will write here x, okay. And now here this is the function, I need to pass some value, that is the x, and let's see, this is the outlier, 100 is the outlier inside this data. Easy, tough, क्या हुआ? That is the any value, that is the dynamic. नहीं, data means you need to pass one value, that is a variable. Means inside this bracket how many value you need to pass? Only one. You got my point? Okay, that's why I written here x. Anything you can pass, x, y, z, anything, that is the dynamic. Are means now you detected salary. Salary is equal to this one is the outlier. Use this one, df dot salary equal to this thing. You will get that row as a true when you pass. करके दिखाओ क्या? This is a df dot salary. ये है. अभी क्या करना है? Equal to what is the your outlier? 186 960. अभी क्या चाहिए आपको? True. Okay. बस ये वाला आपका न्यू डेटा है, ये डेटा रिमूव करना है. एंड नॉट इक्वल टू ले लो, नहीं तो आपको वो रिमूव हो जाएगा. इफ यू वांट टू नॉट इक्वल टू, remove that row. Now this data you can consider for your predictive and any analysis. Here only salary outlier I removed, another outlier also you need to remove, right? Then it will work. Some means you understood the concept, right? Okay, so here means when you draw the box plot, okay, I quickly try to draw. This is the means, I assume that This type of the plot you seen, right? Okay, this is the box plot, and you just try to change the color. Okay, so now, okay, so what is this one? This is the Q1. How to close this one? Okay. Okay. So when we talk about the box plot, this is the middle value, okay, and this is actually median, okay. This is actually median, okay. So what is the use of the median? Median actually, when I talk about the okay, this one is the one, two, three, 4, and 5. Can you quickly calculate the what is the mean of this value? 3. So mu is equal to 3. Can I write? Okay. Now, and what is the median? Median is also 3. Is 3. Okay. So now let put one more thing like 100. Can you calculate what is the mu? 2, 3, 15 and 115. 115 divided by how much? Quickly calculate. 19.16. And what is the mean? Mean is 4. Mean is 4. Okay. So here mean is 4. Means you can say when I'm sorry, median. Median is 4. So what is the thing? When we take the median, median is good to deal with the outlier. Means now here variation with respect to the median is less. Are you getting my point? When you compare with the this mean. So mean is not always useful. So many times the people will take the median, and on the basis of that they try to predict, okay, what are the outlier is present inside the data. Okay, so now this is the point. Okay, so this is the median, and this is generally known as a Q2. So when we talk about this is the your minimum point. How to calculate the minimum? As per the means, if outlier we means remove the outlier, then what will be the minimum maximum that try to see. So this is the Q1. Q1 means 25 percentile. This actually show 25 percentile below this, below this data present. Okay, this is the Q2 is nothing but the median, that is the mid value. Okay, below that 50% data is present, and obviously that is the median, that is the mid value. Below that 50% data in the left side, or you can say below. Okay, and this is Q3, that is the 75%. Then where one more concept came, that is the IQR, that is the IQR. And what is the IQR? That is the interquartile range. Interquartile range, and that is nothing but Q3 minus Q1. That is nothing but Q3 minus Q1. Okay. So now this IQR will help me to identify what is the minimum value that is inside the means that follow the normal distribution and stats rule. Okay. So what is the IQR and what is the minimum? And this is also known as what we can say minimum fence, or okay, just take minimum only right now. So minimum mean as per the box plot is nothing but Q1 minus IQR. Q1 minus IQR if you do, then you will get this value. And Q3 plus IQR, if you do Q3 plus IQR, then you will get this max wala value. And outside this anything is present, that is the outlier. That is the outlier. Are you getting my point? Outside anything is present, that is the outlier. Okay. So now let's take the data and try to do this thing in practical. Okay. Hmm? That is the max. Okay. So now when we talk about the IQR, on the basis of IQR we try to remove. Okay. So now just take data. We have the data, na? 1, 2, 3, 4, 700. Okay. This is the data only we try to take. And now what when we talk about the median also means you can identify like sorted data set and you will get the sorted means by default that is the ascending order. Okay, so that I think that function you know na. I don't know. Data dot sorted, and here you can pass the data and this will be sorted. 1 minute. So I think it will work. 1 minute. Okay, okay. Data just sorted you need to pass. Then it will be sort. Okay, so many time it will be not in the ascending order. So you can make the ascending order. Just pass sorted and data. You will make the data in the sorted manner and the mid value here 4. So you can say median is 4 in this data. Okay. So now what is the q1 and what is the q3? Okay, that we try to identify. Okay, so I just try to see okay, what is the q1 and what is the q1 as we discuss in the graph. What is the q1? Q1 is below 25 percentile whatever the data is present. Okay, so when q1, so what you need to do, np dot, there is the, when you press the tab you will get the option percentile. That percentile is already inside present. Okay, you can even write also and you can search also. Okay, both the option I will, and just pass the data set. What is the data set here? Means data is data, means the name of the data is only data. Now what when you press this one it will tell okay what the thing you need to pass. Aq means percentile you need to pass and these two thing you need to pass. Even you can explore more, but now I just pass. Okay, what the thing I needed till 25, that only I need. Okay, and let me know what is the q1. So this is the q1, that is the 2.75. so below means 2.75, below that 25 percentile data is present. Are you getting my point? Okay, now you want q1 and q3 both the thing, then only I can calculate the iqr. Then only I can calculate the iqr. So let's try to do both the thing in the one line only. Okay, so q1 comma q3. Okay, and here I will pass this two thing means I need to pass inside as a one variable. So I will take the list. huh? Acha, q1 and q3 both I need to call. You got the value of q1 and q3? What is the iqr? q3 minus q1. What is the q3? I means already done, already I define na. Now if I call the iqr you will get the 3.5. Now I want to see the lower fence, that is actually known as a lower fence, lower value inside the this box plot. Now in the lower fence what you need to do, that is nothing but the q1 minus 1.5. Okay, I'm sorry, that is a minus 1.5 iqr. Okay, I wrongly is mentioned. So when we talk about the, this is the box plot. Okay, I quickly try to draw. We have less time, 1 minute. This is the box plot. This is the Q1. This is the Q3. This is the Q2. Okay. So what is the lower fence? Lower fence, and this is the minimum value. This is nothing but Q1 minus 1.5. Actually, I forgot to implement minus 1.5 IQR, and this is the Q3 plus 1.5 IQR. 1.5 into IQR. That is the means a rule, a states rule. Ah, so your data will come inside this. Okay, inside this one. For identifying the outlier, this is the rule. Okay. Now, okay, कहाँ थे? Okay. So that mistake actually I made. Now 1.5. Okay, star IQR. This is the lower fence. Now you can call the what is the lower fence. It will tell you this is the lower fence. Okay, minus 2.5 is the lower fence. Okay, so if any value get below than this, means if you get the value minus 3.5, that is outlier. Are you getting my point? Minus 4.5, that is the outlier. Now what is the upper fence, or you can say higher fence, is equal to Q3 minus no plus 1.5 star IQR. And now if I call what is the higher fence, just let me know higher fence. That is the 11.5. That is the 11.5. Okay. Okay. So if any value above than 11.5, it will become as a outlier. So in our data, any value which are above than out means this 11.5, any value present or not? Yes, 100 is present. That is the outlier, right? Ah, that is outlier. Okay, as per the rules. Okay. Now, uh, डेटा चेंज रहेगा. हाँ, एक नंबर जो भी है चेंज है मतलब. Okay. Now, okay, the same thing you can plot also na. So now what we did, that only I try to plot box plot, right? SNS dot box plot and pass your data, you will get the your plot. And here you can see this is the 100, this one is the 100, and this is the outlier. This is the outlier. This is the 100. Only one value which present. This is your higher fence. This is your lower fence. This is Q2. This is Q3, and this mid value is median, or you can say Q2. This is the Q1. I'm sorry. So like that, box plot also give you the idea how many outlier present. In means data visualization also you can see. Okay. Any doubt? Now, can you identify the outlier on the basis of IQR in the our data frame df.salary? Do it. So what you need to do, you need to make a one function, then only you can call. Okay, so this one the function, and you can pass any data, means df.salary, df.experience, whatever the thing is present, you can easily identify the outlier, and you can remove that outlier for your further analysis. Okay, so this is I think more than enough for today class, as and we conclude. Tomorrow we will take what we can take. One case study we will take.